This question is 3x minus 5 over x plus 2 is less than or equal to 2. So this is what we call a rational inequality. I need to compare it to 0. So I'm going to rewrite it as 3x minus 5 over x plus 2 minus 2 is less than or equal to 0. And then what am I going to do? I would like to get a common denominator here. And I'd like to rewrite it as a single fraction. So what I'm going to do is I'm going to take 3x minus 5 over x plus 2 plus negative 2 over 1. That's the same thing as minus 2. My common denominator is x plus 2 times 1. So to build our new fractions with the common denominator, 3x minus 5 was there before, 1 is new. Negative 2 was there before, 1 was there before. X plus 2 is new. So that this fraction becomes 3x minus 5 over x plus 2. And this fraction becomes negative 2x minus 4 when we distribute over x plus 2. So we're going to add these together, right? So we're going to take 3x minus 5 over x plus 2 plus negative 2x minus 4 over x plus 2, which gives me everything over a common denominator. That was my goal. So we get 3x minus 5 plus negative 2x minus 4. 3x minus 2x is 1x. Negative 5 minus 4 is minus 9 over x plus 2. That's what that simplifies to. So after all of that work, the problem has become x minus 9 over x plus 2 is less than or equal to 0. Well, to do this, we're going to go ahead and solve it as an equal and then do our various tests to see which intervals are true and which intervals are false. So let's do that. X minus 9 over x plus 2 less equal 0. Well, solve it as an equal. X minus 9 over x plus 2 equals 0. When is a fraction 0? When the top is 0. So x minus 9 would have to equal 0, so x equals 9. So when x equals 9, this whole fraction is 0. So when I get to 9, that will be a solid dot because it is less than or equal. Now, division by 0, 0 downstairs is not allowed. So x plus 2 cannot be 0. So let's find out what it is. When does x plus 2 equal 0? When x is negative 2. So that is not allowed. So when I lay out my number line, negative 2 has to be an open circle. So we'll do that. We'll lay out our number line. Make sure you do it in order. Negative 2 comes before 9. Negative 2 is an open circle because it is not in the domain. It makes the bottom 0. 9 is a closed circle because it makes the fraction 0 and it's less than or equal. So we've got to choose numbers in each interval to see if it's yes or if it's no. Between negative 2 and 9, the obvious choice is 0. Beyond 9, I think I'm going to choose 10. Beyond negative 2, I think I'm going to choose negative 3. So let's do 0 first. 0 minus 9 over 0 plus 2. Is that less than or equal to 0? Is negative 9 over 2 less than or equal to 0? That's yes. If it's yes, you shade it. Now beyond 9, if I go to 10, That gives me 10 minus 9 over 10 plus 2. Is that less than or equal to 0? 10 minus 9 is 1. 10 plus 2 is 12. Is that less than or equal to 0? Is 1/12 less than or equal to 0? That's no. So I do not shade there. And then my last slot here is -3. So we'll plug -3 in for x. So -3 minus 9 over -3 plus 2. Is that less than or equal to 0? That is -3 minus 9, -12 over -1. Is that less than or equal to 0? Is 12 over 1 less equal to 0? That's also no. So according to this, my answer will be round bracket, -2, 2, 9, square bracket. Now let's visualize this and see if we can identify that. So this time, I think I'm going to go to Desmos, if I can. And I want to look at what we have there. I want to make sure you know what our original question was. Our original question was here, 3x minus 5 over x plus 2. Where is that less than or equal to 2? So I want to try to answer that question. So again, 3x minus 5 divided by x plus 2. So that's that red function. Where is that less than or equal to 2? So y equals here would be good, probably. And then y equals 2 would be good here. And what do we have? 3x minus 5 over x plus 2 less equal to 2. This is what I have. And where is it less than or equal to 2? Well, certainly here, until I get where? Until I get there, until I get to 9. But what's happening over here? Because at some point it jumps to be bigger than 2. So I think I need to adjust my window to see this a little bit better. I'd like to see some more y. So let's do this first off so we can see all of those numbers. And let my y go from maybe -20 to 20. So we can see what's happening here. So where is it less than 2? Again, underneath this blue line is 2, and we can see here, there's 9, 2. When I go beyond 9, right, the red graph is above 2 all of a sudden. So to the left of 9, it is below to the left of 9. I'd like to get on this graph if I can. There we go. You see how the y value is below 2. The y value is below 2. The y value is below 2 until I get to what? When does it change? You see, all of these y values are below 2. Until I get to -2, and then boom, on the other side of -2, boom, it jumps to way above 2. So between -2 and 9 on this range, from -2 to 9, the red function, 3x minus 5 over x plus 2, is less than the blue function is less than 2. So that's what we were looking for, right? 3x minus 5 over x plus 2, where is it less than or equal to 2? What did we say the answer was? From -2 to 9, right? Not including -2, that was our asymptote on the graph, right? Including 9 because it's less than or equal to. So from -2 to 9 is what that shows us. And you see how -2 to 9 here, the red graph is indeed underneath the blue graph.